Welcome back. My name is Greg Gregson, and today I'm joined by NASA scientist Tyson deGrasse Neal. Congratulations once again on launching the Curiosity rover to Mars. Thank you, we're all very proud of it. And I'm sure with all the batteries it has, it'll last for years to come. Well, we don't have those. Yeah, we don't have solar panels or batteries or anything like that. So how does it even get power? Great question. Powering rovers, spacecrafts, and other vehicles in space has always been a challenge for scientists. First of all, they're extremely far away from us. And there are harsh limits on what can and can't be done in space. Thankfully, scientists have been developing new and more innovative ways to make our rovers last for extremely long periods of time. The Curiosity rover is the perfect example since it uses the Seebeck Effect. Basically, it makes power. To start, let's think about what power is. In a circuit, power is partially created by moving electrons or current. Think like a river. Normally we would just pop a battery in our circuit because batteries create current, but this doesn't last for long periods of time. However, the Seebeck effect is different because instead of using a battery, it uses temperature. Let me break this down a little. In a metal wire, electrons are floating freely and independently and are pretty evenly distributed. However, if you heat one end of the wire, this will change. Temperature is technically the average thermal energy, and in the case of electrons, that means movement. So when you heat up the end of the wire, the electrons on that side will become more active. Pretend you're watching a marathon. As the race progresses, the few faster runners pull ahead and spread out, while the other runners stay clumped together. The same thing happens with the electrons in a heated wire. The heated side will become less dense since the electrons are moving faster, and the cooler side will become more dense. So our electrons went from this to this. Clearly, they moved. And if you remember from before, moving electrons or current is exactly what's needed to create power. The Seebeck effect sounds amazing, almost too good to be true. If making power was this easy, why don't we always do it? Well, to use this effect, we need a constant source of heat. And on Earth, that would probably just result in the burning of more fossil fuels. Thankfully, scientists have found a solution to this heating problem, plutonium-238. This isotope was produced as a byproduct of atomic testing during the Cold War, so there's only a very limited amount of it. However, because of its longevity, it serves as the perfect heat source for the Seebeck effect, which is exactly why the Curiosity rover used it to travel to Mars. And this isn't just limited to space. If we can find the perfect heat source, the perfect method for utilizing the Seebeck effect, we could create clean, renewable energy for us all. Thanks for watching.